Ever wonder how we make industrial processes, more efficient? Like, how do we get things running smoother and faster? Well, today we're going to take a deep dive into how scientists are tackling those roadblocks in biotechnology, especially when it comes to making organisms tougher.
Yeah, we're talking about these things called inhibitors and repressors, right?
Exactly. Those are kind of the focus of our sources for this deep dive, really trying to unpack how researchers are engineering these microbes,
Making them tougher for all sorts of industrial applications. Yep.
basically creating those super resilient strains that can handle whatever we throw at them.
Our mission today, to figure out the strategies, those clever techniques they're using to make that happen.
So inhibitors and repressors, kind of like big words, right? Can we break it down? Like,
Uh,
what are they actually doing in these industrial settings?
Sure. So think of inhibitors as like molecules,
Okay.
and they can kind of put the brakes on these crucial enzymes.
Okay, enzyme.
The workhorse is the cell, right? The
Yeah.
ones driving the production of biofuels, all sorts of things. Inhibitors mess with them, reduce how well they work.
So the whole process slows down.
Exactly. Less efficient.
Like throwing a wrench in the works, basically.
Yeah, good analogy. And then you've got repressors.
Okay, what about those?
They're proteins, and they can think of it like turning down the volume on specific genes.
Interesting.
It's like temporarily locking away those instructions, the blueprint for a key part of the production line.
So the cell just makes less of certain proteins.
Yep, exactly.
So these inhibitors and repressors, they're like natural speed bumps in the whole manufacturing process.
Right.
So why is it so important to create organisms that are like insensitive to them? Why do we even care?
Well, imagine this, right? If we can engineer microbes to just ignore those inhibitors or repressors,
Okay, yeah.
boom, the efficiency skyrockets.
Oh, I see.
More of that desired product, faster, and potentially cheaper, too.
That's a big deal.
It really opens up so many doors.
And the sources, they talk about this two-pronged approach, right? First, understanding how these things work,
Yeah.
and then actually finding those rare organisms that can resist them.
Yeah. It's fascinating, isn't it? You need to know your enemy, right?
Right.
Researchers get deep down into how a specific inhibitor messes with an enzyme's function, or how that repressor protein actually blocks a gene.
Knowing the how, the mechanism.
Yeah, and that gives them the clues to find workaround solutions.
But once you know how they work, the big question is, how do you find those mutants, those tough guys who can resist?
Well, that's where things get really clever.
Okay, tell me more.
Scientists, they use these ingenious screening and selection methods.
Okay.
Imagine you expose a whole population of microbes to, say, an inhibitor, and then you see who survives, right?
Oh, right.
Who can still thrive. Those are your naturally resistant mutants.
So it's like a microscopic survival of the fittest competition going on in the lab.
Exactly.
And the sources, they mention that there are actual examples of these resistant strains being isolated. It's not just theory, right?
Oh, absolutely. It's happening. Researchers have found them, isolated them. It shows you just how powerful and practical these techniques are.
Like real-world applications making a difference in how we produce things.
Yeah, think about biofuels, certain pharmaceuticals, all kinds of possibilities.
So, listener, what's the big takeaway here? What do you want them to walk away with?
I'd say remember this. Engineering microbes to resist inhibitors and repressors. Huge deal in industrial biotechnology. It's really about optimizing those biological factories.
And for anyone trying to wrap their head around this field, get up to speed quickly.
Yeah.
Understanding this capability, that's a shortcut. You suddenly see the potential, how we can produce so many things more efficiently.
Absolutely. The aha moment is realizing that scientists aren't just watching things happen, they're actively shaping them.
Manipulating those processes at the molecular level, right?
Overcoming those natural limitations, pushing innovation forward. It's exciting.
So, in a nutshell, we've explored how scientists are creating these mutants.
The ones that can stand up to those inhibitors and repressors, yeah.
A critical technique for improving those industrial processes.
And listener, here's a final thought.
Okay.
This ability to manipulate these biological controls at such a fundamental level
Yeah.
to make organisms more resilient.
Think about the possibilities.
Could this lead to breakthroughs in other fields beyond industrial biotech? What other limitations might we learn to overcome? It makes you wonder, doesn't it?
It really does. Thanks for joining us on this deep dive.